So I'm going to make a two-part video here on derivatives and antiderivatives involving the trig functions, all six. I'm going to do simple ones where the angle gets a little harder, but where the angle is the inner. And then we're going to look at some examples of where the trig function is the inner. So I'm going to do this in two parts so that the videos don't get too long. So anyways, here's a list of our derivatives that we want to study. And here we start with some very simple ones where the angle is just multiplied by some constant. And we have to do the chain rule. So the angle is, of course, the inner function. Okay, so what we end up doing is derivative of the trig function, keep the same angle, because that's keeping the inner, derivative of the trig function, which is the outer, keep the same angle, times derivative of the angle, because that's derivative of the inner. So if the angle, then the angle is just a constant. Actually, I didn't mean it to say it like that. When the angle is just multiplied by a constant, because it's not just a constant. That wouldn't make any sense. When the angle is just multiplied by a constant, okay? I want you to skip the u sub. So we're going to take a couple derivatives, and then we're going to think about what this would mean for antiderivatives, all right, where the process is the opposite. Anyway, I encourage you to pause the video, try these first two derivatives before I just give the answer. All right, so for the first example, derivative of cosine, we know the derivative of cosine is negative sine. And see, notice how I leave a space here? Because I know that when I take the derivative of the inner, right, the derivative of the angle, so I keep the angle exactly the same. So this needs to be negative sine 7x, but times the derivative of the angle, which is 7. Okay, so that would be the answer here. That's a not very nice looking x here. Okay, now for secant, the derivative of secant is secant tan. Okay, so answer here would be, we want to put the constant in front. So when we take the derivative of the angle, it ought to go in front. So derivative of the angle is going to be 10. And then I look at, okay, what's the derivative of secant? And it's secant tan, but the angle stays exactly the same. So secant 10x tan 10x. Okay, so you should notice commonalities in these. Notice how every time I do these, the angle ends up being the same. I'm finding the antiderivative or the derivative of the function, right? But I always end up with the same angle. So moving on to antiderivatives. Okay, let me do one with you, and then hopefully you can generalize this. Now, this is so confusing because the derivative of cosine is negative sine, right? But then the antiderivative of cosine is positive sine. Okay, so for this one, we need positive sine. And again, the angle is going to stay the same. Now, I could have let that angle be u, but I'm not going to do that because I don't need to. I'm smart enough to not need u substitution here. Okay, what's going to happen with the 4? Remember when we were taking the derivatives, right? The 7, the 10 ended up in front. What happens when we're doing the reverse process? Okay, what happens to the 4? Does the 4 end up in front? Okay, and I hope you recall that it is the reciprocal of the angle. Okay, and then of course don't forget plus c. Okay, so that being said, I'm hoping that you can do the next two. All right, without needing U substitution. The next section where the angle gets a little more complicated, we'll use U substitution, but we don't need it here when the angle is just a constant. All right, so try the next two. Okay, and if you're back, the function whose derivative is secant squared is tangent. Okay, and so what happens with the 6 is we get 1/6 tangent 6x. Okay, so see how the angle never changes. The trig function changes, right? Because we find the derivative of, or the antiderivative, and the constant comes out in front when it's derivative. The reciprocal of the constant is in front when it's antiderivative. And so what function has sine as its derivative? Well, cosine, the derivative of cosine is negative sine, so I would need the negative cosine. It's so easy to mess up on your signs with this, right? Because it's opposite when I do it this way. So right here, derivative of cosine, negative sine, but then when I have sine, antiderivative, negative cosine. Okay, and then again, what happens with that 9x? It's in front. Okay, so I want you to look at the commonalities, right, and make generalizations. Angles always stay the same. I'm just using the derivatives or antiderivatives. Constants go in front for derivatives. Reciprocal of constants go in front for antiderivatives. Okay, so now let's go down to this section and see, well, what happens when things get a little more complicated? Okay, so what if the angle is not just some constant times x? So if we look at this first one, so again, following exactly what we said, derivative of the outer, so the derivative of sine is cosine, keep the angle the same. So the angle never ever changes. Okay, and notice I left space in front because then I need to do the derivative of the inner of the angle. And we want to put the 2x in front because otherwise we'll get confused about, you know, whether the 2x is part of this angle or, you know, whether it's not. Okay, so again, angle is always the same. The only thing that changed is I took the derivative of the trig function and then I had to multiply by the derivative of the inner. Okay, so now let's look at some antiderivatives. So here, my function is unfortunately the angle. So again, this is the angle. Sometimes I tell students to draw a theta around it to remind them that this is the angle. The angle is the inner function. Okay, so we're going to let u be x squared minus 3. All right, and then we're going to do our usual thing that I feel like we've done 5,000 times, where du dx is 2x. And if I didn't have, because see, I see the derivative of u as part of my integrand. I almost forgot to put it in there, and the problem wouldn't have worked if I didn't have that x. You can tell I squeezed it in there. Okay, but the x's have to cancel or this couldn't work. Okay, so then du over 2x equals dx. Okay, so now I come and I substitute back in. I think I'm going to do that right above it in green. Okay, so I had this x, then I have sine u, and then dx is du over 2x. And again, I bet some of you can skip this step, right, and immediately say, okay, a half's going to go in front. I know the x's are going to cancel. Like you could probably write from here just say, I know what's going to happen. I know the x's are going to cancel. I know the half's going to go out in front. And so now we haven't integrated yet. Now we need to figure out what's the antiderivative of sine. Which function has sine as its derivative? And this is du. And so it doesn't matter that I have a u in here, because I could go up here and I could replace, the x just stands for the angle, right? So all of these can be, right, just replaced with a u. So what function has sine as its derivative? Well, that would have to be negative cosine to get positive sine. Okay, so come back here and I get, sorry, my work is getting messy here. 1/2 negative cosine u. So I'm going to put the negative in front, negative cosine u. Okay, but then, plus c, of course. But then in place of u, I put the angle back in. So again, I'm really trying to show you that emphasis, whether I take the derivative or whether I take the antiderivative, right? My final answer always ends up having exactly the same angle as what I started with. The angle never changes. Okay, so that's how you're going to do some quality control on your test and quiz. Is you're going to make sure whatever you're doing, derivative or antiderivative, your final answer has the same angle as what you started off with. Okay, so this would be the final answer here. All right, and like I said, I could have done u substitution on all of these, right? I could have let u be 9x, u be 4x, right? But when I would take the derivative, I'd end up getting du over 9 or du over 4, right? And that's how I would get the 1/4 and the 1/9. So I'm hoping we're ready to skip the u substitution on these simpler ones. Now down here, secant x cotan, right? And this is the angle, right? Because there's no such thing as a trig function without an angle. Okay, so here the angle is x cubed, and so I know my answer is going to be, now let's say I don't have a negative here, but I'm working with this one, right? Because the antiderivative of this gets me back to just cosecant. So it's going to be negative, right? Because this answer was negative. Down here I have a positive. So I know, here's one thing I know about my final answer. I know my final answer has to have the same angle. Okay, and it's going to be negative cosecant, right, with the same angle. I know it's going to end up like this, but what else am I going to have, right? Am I going to have anything else, or is that going to be it? So what I do is I let u, right, so this is, some version of this is my final answer. So I'm going to kind of like box it off, and let me change colors just to kind of highlight that I'm doing something different here. Okay, so I'm going to let u be x cubed. Okay, because that's, the angle is the inner. Du, so do I see the derivative of u in my integrand? And I certainly do, because I see an x squared. Right, so this is going to cause that x squared to cancel. It would have to, or this wouldn't work. And then what's going to happen to this 3? Right, so du over 3x squared is equal to dx. Okay, so look what happens when I put that up here for dx. Okay, the x squareds would cancel. That's got to happen. Otherwise, this wouldn't work. So these cancel. The 1/3 would go out in front. and this becomes u, and this becomes u, right? But I already looked up here and noted that the antiderivative, because the derivative of this is negative cosecant cotan, the antiderivative of cosecant cotan is negative cosecant. And so again, doesn't matter if I have an x or a u. Okay, so I end up with a 1/3 out in front. So that's what's missing from my answer, was the 1/3, okay, that I got from taking the derivative of u. Okay, but again, oh, don't let me forget plus c. Again, notice, angle is the same as what I started with, right? And then I just had to adjust for the constant from my u substitution. And certainly I need to have these memorized. Okay, so I'm going to take a break here because they say you're not supposed to make your videos more than 10 minutes or students lose interest, and this one's 16. So I will end here and start the next video separately.